So we're in section 4.1 looking at divisibility and modular arithmetic. In our last video we covered the division algorithm, how to use it, how to find a quotient and a remainder. In this video we're going to start with congruence modulo m. This is a relation that we're going to define on the integers. So suppose you have two integers a and b. So suppose a and b are integers, and you also have a positive integer called m. So a and b are integers, and m must be a positive integer. We say that a is congruent to b modulo m, and the way we denote that, we wrote a with triple bars, a b, and then in parentheses we write mod m. Provided the following happens, m divides a minus b. So a is congruent to b modulo m precisely when m divides a minus b. Now focusing here, I'm going to highlight this, m divides a minus b. We've defined that in the past. What does that mean? That's equivalent, we said, to saying a minus b is a multiple of m. In other words, equals m times some integer k. This is for some integer k. That's what it means for m to divide a minus b, right? We said that back on our first day of class when we were looking at divisibility. Now if I were to add b to both sides of this last right equation, I get a equals, let's see, b plus mk for some integer k. So these are three different ways that we can state a is congruent to b mod m. So a is congruent to b mod m I have circled in blue, and you have these three other ways to say it. M divides a minus b minus b is a multiple of m, or a equals b plus a multiple of m. I think probably the last one, I'm going to check here in yellow. That might be the most useful one for us. I don't know. I don't know what you find most useful. That's the one I find the most useful. So we're actually going to determine if a is congruent to b mod m in some exercises here. Determine if a is congruent to b mod m. Okay, so number one, we have that a equals 17, b equals 14, and m equals 3. So to figure out if a, 17, is congruent to b, 14, modulo m, 3, we want to see if we can write an equation of this form. A equals b plus m times some integer k. So replacing a with 17, replacing b with 14, replacing m with 3, can we find some integer k here that makes this work out? In other words, is 17, 14 plus 3 times something? And yeah, your k here is 1. So yes. That works out. Number two. Let's check out if the next one works. What if a is negative 28, b is 2, and m equals 5? So we're going to try to satisfy the equation a equals b plus mk. A equals b plus mk. Well, here a is negative 28, b is 2, m is 5, and can we enter a k there that makes this work out? So is negative 28 equal to 2 plus 5 times something? Well, it would have to be a negative number. What could we do here? Let's try, how about -6? Plug in -6, would that work? Yeah, -28 is 2 plus 5 times -6, right? 2 plus -30 gives you -28. So that would check out. So this is a yes as well. Let's try number 3 here. Number 3, here I have A is 9. B is -16. So A and B, they can be positive or negative, but M must always be a positive integer. Remember that when you're doing these. That's called the modulus. M is the modulus. Okay, so remember you want to satisfy this equation, A equals B plus MK. And you have to find the K basically. Is there going to be a K that works? If there's not a K that works, then A is not congruent to B. But if there is a K that works, then A is congruent to B. So you got 9 equals -16 plus 4 times. Can you find a K here that works? Find a K here that works. I don't think you can you? Yeah, there's no K that works. For example, if you tried 1, you get -16 plus 4. That would give you -12. No, that wouldn't work. Or maybe I'm just not thinking in the right direction. What if you tried let's see, a bigger number? What if you tried 6? Would that work? That would be what? 24 and -16. 24 plus -16. That would give you 8, right? That wouldn't work. So yeah, the answer here is no, right? This is not correct here. You can't get that formula to work out. So the answer is no. And the reason is 9 is not equal to -16 plus 4 times K for some integer K. It doesn't matter what you plug in for K. Whatever I plug in for K, any number, I'm never going to get out 9. Yeah. I mean, you could go through a list of numbers, right? You could take -16 plus 4 times, I forgot what we just did. What did we just do? We did 6, I think, and that gives you what? -16 plus 24, that would give you 8. That's about as close as you're going to get to 9, but you don't get there. You could try -16 plus 4 times 7. That would give you, let's see, -16 plus 28 is 12. That's not going to get you there. So neither of those is 9. So yeah, you're never going to get to 9. Okay, so the answer is no. 9 is not congruent to -16 mod 4. Okay, let's do a little bit more here. Here's an example. Find 6 integers that B is congruent to. Modulo M. So we're going to give you a B and an M, and we're going to have 6 integers that B is congruent to. We have to find 6 integers. So let's say B were 2 and M were 7. So here on the side, I'm going to do my scratch work. So Read my scratch. So remember the equation for showing that, so A is congruent to B mod M. That's the same thing as saying, this is equivalent to saying A equals B plus MK, right? That's the form. This is my scratch work right here. So I'm going to start off with A's unknown here. I'm going to start off with a B of 2 plus an M of 7. And I'll enter a K. I'm allowed to plug in anything here for K, right? K can be anything for some. This is for some K. It's an integer. So I don't know. Let's pick -2 for K. What happens when we do that? Well, we get what? 2 plus -14. That would be -12. Okay, so that means -12. A is -12. So that means so I'm going to write my answer over here. -12 would have to be congruent to 2 mod 7. So I got one number that's congruent to 2 mod 7. That would be -12. Let's do another one. Let's take A is unknown equals B 2 plus M 7 times, let's pick this time -1 for our K value. You can pick anything for K. So we have what? 2 plus -7. 2 plus -7 is -5. That means A here is -5. So that means -5 is congruent to 2 mod 7. So I'm going to write underneath my blue there, I'm going to have another one. -5 is congruent to 2 mod 7. All right, let's do this again with a different value of K. Maybe K equals 0 this time. So let's take A equals B, which is 2, plus M, which is 7. And for our K value, K can be anything. Let's pick 0. So I'm going to have what? 2 plus 0 is simply 2. So my A here is 2. So that means, in blue, I'm going to write my A is 2. So 2 is congruent to 2 mod 7. So important fact, 2 is always congruent to itself. So a number is always going to be congruent to itself. Let's do another one. Scratch work on the side. A is going to be equal to B, which is 2 plus M, which is 7 times a K value. Let's go to +1 for our K value. So we got 2 plus 7, which is 9. So my A is 9 here. So that means 9 is congruent to 2 mod 7. And we'll do, how many do we have to do? I think 6, right? We got 4 so far. Let's do another 2. So A equals B2 plus M7 times, and let's plug in this time 2 for our K value. So we got 2 plus 14. 2 plus 14 is 16. So we have 16 is congruent to 2 mod 7. And we got one more to do. A equals 2 plus 7 times, for our K we're going to pick 3, and we're going to get 2 plus 21 is 23 for A. So that means 23 is congruent to 2 mod 7. So our answers are here in blue. I found 6 integers that 2 is congruent to modulo 7. So -12 is congruent to 2 mod 7. -5 is congruent to 2 mod 7. 2 is congruent to 2 mod 7. 9 is congruent to 2 mod 7. 16 is congruent to 2 mod 7. 23 is congruent to 2 mod 7. So basically, notice that here in the middle, I'm highlighting this in yellow. You could start with that one in the middle. 2 is always congruent to itself. And notice what we've done to go up. We've gone up 7, right? You add 7 to get to 9, and then 7 to get to 16, and then 7 to get to 23. You just add your modulus, or you could go backwards and subtract 7. So subtract 7 to get to -5, subtract 7 to get to -12, and you can keep going down or up, either way you prefer, subtracting 7 or adding 7, and you'll continue finding numbers that are congruent to 2 mod 7. Let me draw this in a diagram, actually, what's happening. So we have this concept of mod 7. So mod 7 has basically 7 numbers. You got 0. I'll make a table. Let me make more space here. I'll call this mod 7, a table for mod 7. It's a number system, mod 7. So we'll start off with 0, and then 1, and then 2, and then 3, and then 4, and then 5, and then 6. So this is the mod 7 number system. 0, 1, 2, 3, 4, 5, 6. And then when you get to 7, that wraps back around here. It's congruent to 0. And then 8 would be the same as 1, and then 9, and then 10, 11, 12, and then 13. And then once you hit 14, that wraps back around where 0 and 7 are in that same column there. And you go 15, 16, 17, 18, 19, 20. And once you hit 21, that wraps back around at the beginning column. Once again, so 21 will be in the same column with 0, 7, 14. After 21 comes 22, 23, 24, 25, 26, and then 27 ends up in the same column as 20. Or you could go above with some negative numbers. So I had 0. If I went backwards, I'd have negative 1 in the same column as 6, and then going backwards, negative 2, negative 3, negative 4, 5, negative 6, 7. And if I keep going backwards, negative 8 would go above negative 1, and it goes back to negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, and so on. So everything that's in the same column is congruent. So for example, all of these numbers in the blue, in this blue column are congruent. So negative 14 is congruent to negative 7, negative 7 is congruent to 0, 0 is congruent to 7, 7 is congruent to 14, 14 is congruent to 21. Now where we were concerned with the column involving, right, our B was 2, right, our B was 2. So we were actually, I'm going to highlight the one in yellow that we were interested in. We were interested in this one here. I'm highlighting in yellow. And as you can see, these are some numbers that are congruent to 2 mod 7. So negative 12, negative 5, 2, 9, 16, and 23. And we had all those numbers, right? Negative 12, negative 5, 2, 9, 16, and 23 in our list of numbers here. Okay, so that's really what's going on at the core. Now let's do one more example. Number 2. Here our B is 6, and our modulus is 9. So my scratch works here on the right. Remember, you want A equals B plus MK, where K can be any integer. So I'm going to have, let's see, A could be 6 plus 9 times negative 2. A could be 6 plus 9 times negative 1. A could be 6 plus 9 times 0. A could be 6 plus 9 times 1. A could be 6 plus 9 times 2. A could be 6 plus 9 times 3. Do I got 6 yet? 1, 2, 3, 4, 5, 6. I do. Let's calculate these A's. These are all numbers that are congruent to 6 mod 9. Now the first one's going to be 6 plus negative 18, which would be negative 12. The second one's going to be 6 plus negative 9, which would be negative 3. The next one will be 6 plus 0, which is 6. The next one will be 6 plus 9, which is 15. The next one will be 6 plus 18, which is 24. And the last one will be 6 plus 27, which is 33, I believe. So the pattern you should see these jumping up by 9. So when I look at negative 12, I add 9, I get negative 3. I take negative 3 plus 9, I get 6. 6 plus 9 is 15. 15 plus 9 is 24. 24 plus 9 is 33. Yeah, that's correct. So writing the actual answers here on the left side. So that was scratch in green. On the left side, I'm going to write my real answer. I'm going to have negative 12 is going to be congruent to 6 mod 9. What else? Negative 3 is going to be congruent to 6 mod 9. 6 is going to be congruent to itself mod 9. That's always a given. 15 is congruent to 6 mod 9. 24 is congruent to 6 mod 9. And 33 is congruent to 6 mod 9. There are our answers. We found exactly 6 integers that are congruent to 6 mod 9, which are negative 12, negative 3, 6, 15, 24, 33. All right, so in the next video, we're going to look about how to do some modular arithmetic with this congruence relation.